Hello guys, welcome to the course on electrical machine. This is a fifth video lecture. In this video lecture we will see the basic property of inductors, few formulas, last year engineering service questions and previous gate years question, and most important dot convention. Let us begin. Suppose friends, compare these two circuits. There is an coil wound on a core and we apply a DC current here, and there is a second core, we apply a AC current here. See, for both these two, this is an options. In case 1, for inductor, if we allow DC current, option 1 produce flux, option 2 produce EMF, option 3 exhibit inductance, option D all. The same option is given for question B, where an AC current flow. Same 4 options. Now you say which of the option is valid for A question and which of the valid is B for B question. One thing you note friends, if you apply DC to an inductance, only flux will produce, because the flux which is produced is stationary with respect to time. See, here conductor is stationary and flux is stationary, so there is no EMF induced. For production of EMF, there will be a conductor, there will be a flux, and there should be a relative motion. Either conductor has to move like in generators, or flux has to move like in transformer. So these two cases have failed. So in A question, only flux is produced. In B question, all the options are correct, because AC is produced now, flux is time varying in nature. So flux is produced, EMF induced, inductance is exhibited, all the above. One point you have to note here is that for this case, A case, EMF is induced momentarily when suddenly switch is closed and flux is varied from 0 to time t. After time t, flux will saturate. See here, after time t, suddenly current has raised. Suppose this is like an impulse. In this time period, the flux will change. After this time, flux remains stationary. So EMF is 0. And this is the case that normally you say transformer won't work in DC. If you give DC, transformer will burn, because there is no EMF induced, there is no opposition to the primary EMF, and I equal to V by Z. Z of the transformer is very less, so V by Z is very high, transformer will burn. Let us see how much this is valid. Actually, this is not 100% true. Let us see in future classes. I will tell what exactly happen if you apply a DC voltage source to a transformer. Let us see. Now for this moment, for case A, answer is 1. For case 2, answer is 4, means all the above. Second thing, you must know the basic equation that energy stored and inductor is B square by 2 mu. Now the similar case for capacitor, you just comment in the comment box. Once again, I will remind you that I have a separate channel called Electrical Master, where I am presently discussing previous year's engineering service questions or any notification. If you want any subject like electronics, or you can say control system, networks, power electronics, any subject you want, you just go there, subscribe there. In any of the video lecture, you just comment there, it will come to me and I will start that subject. Because study IQ also giving me offer at blog electronics. I am thinking whether to teach or not there. For money, I don't think money is matter for me. It will give internal happiness if I give free to all. So friends, just I need your help by subscription. If I get 200 subscription, I will start, because if I start also no one watch, it is waste of my time. Already I am working in a PSU, I have very less time. Since I have started this course of electrical machine, I have to complete. So you just go there and subscribe. Your subscription will motivate me to start any subject you want. So let us see the basic equations, few more basic equation here. This is engineering service means question. Actually the question what they have framed is, they have given L1, I1, L2, I2 and M value. They have told you to find the EMF. Since engineering service is a means is the descriptive one, I1 is varying with respect to time, I2 is varying with respect to time, some complex, but the basic equation you must know this equation. Here, see here, there is a half term here, there is a half term here, there is no half term with m term, mutual inductance. This you have must be kept in mind. Okay, these two equations is just you keep in mind. I thought just to revise it. Let us see third property of inductor. This is important because transformer is a type of inductor. And this is linked to actually saturation of the core. What will happen if you apply DC to a transformer? Actually this is not 100% correct that transformer will burn. Transformer will burn only if you allow transformer to saturate. Like if you take power electronics courses like forward converter, flyback converter, there we apply DC to a transformer and transformer will not burn. Actually this is a, I will separate half an hour on this topic in future classes. Again, once you think this in DC machine, to produce flux you are applying, what you are applying, DC source to do inductance. A coil is there, it acts as an inductance there, that inductance is not burning now, you applying a DC, still it is producing a flux and operating satisfactorily. So that is not 100% correct. If you apply a DC to a inductor, it will burn. Transformer is a type of inductor. So there is a special case I will discuss future. It will take half an hour for me to discuss that with application in for power electronics, forward converter, flyback converter. I will just once touch this topic, friend. Let move ahead. See, the third conclusion is inductor does not allow sudden change in current. If inductor allows sudden change in current, EMF is impulse. See, to change the current, sudden current in an inductor, EMF apply must be impulse. Take a case here. Take a case. This is an graph of current flowing. Now they ask me draw the EMF, or suppose they have changed, they have given the EMF, they ask draw the current waveform. See, E equal to L di by dt. So you take here, suppose there is an inductor of 2 Henry. Take a case, listen carefully friends. There is a case of inductance equal to 2 Henry. It will discuss in networks topic elaborately, but let us touch a topic here. See, there is a sudden change in current in this portion. From 2 to 4 millisecond, there is a sudden change in current. As you know, inductor does not allow sudden change in current, but this current, if we pass through an inductor, see here, how is the EMF? Impulse is the EMF. You just differentiate here. D by dt of constant is 0. So from 2 to 4, from 2 to 4, from 2 to this is 4, actually I missed it, 2 to 4, EMF is 0, and there is a sudden change here, there is a sudden change of voltage here. So if voltage is suddenly changed like an impulse, current will change. This I want to tell you. Just move ahead. See here, take another case. Now the current waveform is like this. Suddenly current is changing, suddenly current is changing, suddenly current is changing here from at 3, at 6, at 9, at 9, at 3, at 3, at 6, at 9, current is suddenly changing. So the voltage is in impulse form. This point you kept in mind. I will discuss this in future classes. Let us now move ahead. This is the basic formula once I have to revise, because inductor is a transformer is a type of inductor. So move ahead. The basic difference between inductor and transformer is, in inductor you can store the energy, in transformer you cannot store the energy. The reason I will discuss forward. You in transformer, if secondary is not loaded, you have to dissipate the stored energy in some circuit. That is, in forward converter and flyback converter, how will going to transfer that what you called as a working flux in secondary circuit. I will discuss in future classes. Let us move ahead. Now talk about dot convention. See, dot convention is not necessary if transformer winding is visible clearly. If you can see the transformer winding and how it wound on a core, you don't need a dot convention. But we cannot see transformer core, it is a completely uh, inside the core, means on core you have wound the winding in core type or in shell type. Cores surrounded the winding, core will surround the winding, you won't see the winding there. And the nature of orientation, so the manufacturer will give dot convention. How manufacturer will produce dot convention? By using dot polarity test, which will I will discuss in future when I discuss open circuit test, short circuit test, sump-net test, and dot polarity test. And let us move ahead, friends. See this topic. If transformer winding orientation is visible, dot convention is not needed. Positive coupling. What do you mean by positive coupling? Just see the definition. I will discuss in 4 cases. These 4 cases I will going to discuss. Positive coupling means two fluxes is adding. Negative coupling means two fluxes is subtracting. Let us take the cases one by one. And this is important. I am going to discuss very slowly. This is very important, very important. Nowadays questions are asking on dot convention. If you see the trend of gate from 2015 onwards, there is a one question in dot convention, though 2019 there is, I think there is no question, but this is an important topic. Take a winding, take this orientation and current flowing, take this orientation and current flowing. See, I have kept a dot here at starting of the winding. Starting of the winding, I have kept the dot. I have assumed that I kept the dot. Manufacturer kept the dot at starting of the winding. This is an assumption. Now, friend, you apply the forefinger in the direction of current. Direction of current, you apply your forefinger, and your thumb will show the current of flux. The thumb will show current direction of flux. Similarly, the orientation and the current direction in both two windings is same. Now you apply the forefinger of your hand in the direction of winding and current. The thumb will show the flux direction. In both cases, flux is produced in same direction. And so this is additive polarity. One point you note here, note. In this case, you note that when in both winding current enters the dot, the flux is in additive direction. When current enter, observe clearly, listen clearly. When current enters the dot at the both winding, the flux produces additive. How you decide that the dot? I assume dot at the beginning of two winding. Means how you oriented? You oriented on this core like this. On this core you oriented like this. And produce a flux. Dotted you kept here. Produce, current is flowing is that, and you kept a dotted here. So this is positive coupling. This is positive coupling. This is positive coupling. Positive coupling, sorry, positive. Now move to the case 2. Now the first winding orientation on the core is kept same. The second winding orientation is changed. You say changed. Now you orient. Now, sorry for that, friend. The orientation on the winding is kept same. See, second core also wound like this, but so this is a dot. Starting of the winding is kept dot. Starting of the winding is kept dot, but now this winding is added to here. So the current flow is now from downwards to upward. See here, clearly see. Primary orientation and secondary orientation is kept same. Orientation is kept same. Orientation is like this. See here, listen carefully. The secondary and primary both are oriented. So primary dot is this, secondary dot also kept at same, because the orientation of the winding is kept same. But the current flow in the case 1, you connected the secondary like this. In case 2, you kept the secondary like this. So current is entering in this way. from downwards current is flowing, from downwards now current is flowing. Now you apply your four fingers in the direction of current, the flux will the thumb will show the flux direction. So now the flux is in reverse direction. See friends, once again listen here carefully. This is the orientation. The flux is, now the current is flowing in this direction. You keep your four fingers in this current direction and thumb will show the flux direction. See, flux direction is in this direction. Flux is in this direction. In primary, flux is in direction. So what conclusion you get? Very very important conclusion, very important. See friends, listen carefully. See, in first current is entering in dot, in second current is leaving, current is leaving. See here, current is leaving. And what coupling you got? You got negative coupling. Both are opposite to each other. In first case, if current entered the dot and current leaves the dot in second coil, the nature of flux is subtractive. This is the actual case of transformer. In transformer always coupling is negative. Why? In future I am going to discuss, but listen the reason now. Because the flux produced in transformer secondary always oppose the primary flux, means phi 2 dash equal is opposite to phi of main field flux. When you keep load on secondary transformer and EMF E2 is induced, it will produce a current such that it opposes the cause. What is the opposite cause of EMF induced? Flux in the transformer. So phi 2 dash is always opposite to phi 2, means transformer is always a negative coupling device. So this case is valid in transformer, not this case. Okay friends, hope you have understood. Let us go for third case. Now the sense of winding of coil B is changed. See, now sense of winding of coil B is changed. This is the winding now friends. Now from downwards they are going to orient like this. From downwards it is going. In case 1 it is like this. In case 1 it is like this. See here, in case 1 it is like this, like this, like this. In case 2 it is from downwards we are going like this. So orientation is reversed. See carefully. Now again second, see how they are added. Now they are added in case like this. So here current is entering dot, in secondary current is leaving the dot. So it is again a negative coupling device. You apply four finger, the flux direction is same as in first and second case. Now you apply the fingers in current direction, you will get flux in opposite direction. So this is also a negative coupling device. Again, what conclusion you got? See, this conclusion is very important friends. Observe carefully. If current entered the dot in primary, if it leave in secondary, this is a negative coupling device. Again, it is an example of transformer. Again I am telling, transformer is always a negative coupling device. If current enters at primary, it has to leave at secondary. Hope you have understood the case. Now go for fourth case. Now sense and current direction changed. Now see, sense and current direction has changed in coil 2, in this coil. Now the dot, see here, see the dot. In third case I forgot to tell why the dot has kept in this place. In this place why dot has placed. See how you oriented. You oriented from downwards and gone like this. Means if you going to orient from here, else you start like this. Sorry friends, you start like this orientation. This is if you start from here, from downwards you are taking, means you are going to tight on this core from this direction. This is the starting. Always if you confused which is starting end, the way you wind such that it will tighten on core. If it is loosen on core, that is not the starting end. From here you started and moved the winding in this direction, it gets tightened on the core. Means you are going to place winding in that direction so that winding is kept stationary on the core. That is called starting winding. So dot is kept in that place. Why dot has kept here? because you are going to orient it from that point so that it tighten on the core. Hope you understand the meaning here. In this case, see, now in fourth case, the dot is kept here, hope you understand, and the current is added in the second coil. So now current entering the dot. In first case current entered the dot, in second case also current enters the dot. You apply the flux direction both in same direction, it is positive coupled. It is called positive coupled, and this is not a case of transformer. Only case 2 and case 3 is an example of transformer. Hope you understood, friends, clearly. Let's move ahead. Now move ahead, friend. Let us see. So what conclusion you get? Coupling is decided by flux direction. Flux direction. But we cannot see flux, so we use dot convention. See, orientation of winding we cannot see. We cannot see flux. So we use dot convention. How dot convention manufacturer decide? Using dot polarity. How the test is conducted, I will discuss when I discuss open circuit test and short circuit test. So see the conclusion here. To get conclusion, dot is placed at either beginning end or termination end, both in the same manner. So beginning and termination end is based on sense of the coil, not by current direction. Sense of the coil means you wind in such a direction, it get tightens on the core. If you remember like this, you will never get wrong. So let us take what observation you got in these four cases. Current enters the dot both coil or leaves the both coil, then coupling is positive. If current enters one, leaves another, in case of transformer, M is negative. So let us see few examples. This will be discussed clearly in networks topics. But friends, let us discuss once to recap before going the original course of transformer. Don't you get bored, because it's my responsibility to just remind you this all. I hope you know. I know you know, but it's my duty to remind basic equation, because transformer is like an inductance. Okay friends, now see, these two inductance is connected. The dot, see, this is beginning and this is beginning. Dot is connected like in this manner. So the inductance EMF, the equivalent inductance is L1 L2 plus 2M. See here, see, you can say dot as a, take an example of battery if you don't understand. Dot is like a big terminal, small terminal is undotted. See again, dotted, big terminal, undotted, small terminal. So these two is added. You know, when negative is connected to positive terminal, EMF get added. So in equivalent inductance is 2M. Take an example here. Take an example in second case. See, again dotted as big terminal, undotted small terminal, again undotted small terminal, dotted big terminal. The equivalent inductance is minus 2M. Equivalent inductance is minus 2M. Or you can say, what example I have given, when current enters dot of both terminals, the inductance is positive. When current enter here first inductance and leave the second dot, the equivalent inductance is negative. Similarly here, the current enters the both dot, equivalent inductance is positive, means it will get higher EMF. So you apply the same dotted terminals here. See, in denominator there is negative, so overall value will become higher. So the equivalent inductance is increased, because this is a positive case na. Current entering both the terminals, so it is positive. We should get equivalent inductance higher. So in this case, see, in denominator there is a negative term, so overall value increases. Take fourth case here. Take fourth case. In one dot terminal current enter, in second dot terminal it is leaving, so equivalent inductance has to decrease. So in this case, in the down, it is not visible here. L equivalent equal to L1 L2 minus M square I am unable to write clearly here. M square by L1 L2 L1 plus L2 plus L2 plus 2m. When you add plus in the denominator, equivalent terms decreases. You have to remember like this. Hope you have understood this. Friend, let move ahead. Let move ahead. Now take this example. See, this example is very important. Friend, please observe. Please observe here carefully. I've told you in the last class that Lenz law importance. I also told you a point. You must remember that you always need not to keep negative sign. You need not to keep negative sign equal to n d phi by dt or equal to minus n d phi by dt. That minus is depend upon the polarity given in the question itself. In the question itself, if it is a negative polarity, you need not to again show the Lenz law here. See that example I am going to discuss. This is an important question. You know all this, but you just rewind once, a little bit concept will be improved. This is my main intention. See here, see this case. See, case 1 is given I1 entering the dot. At second terminal, dot is kept in this winding and positive terminal is given. Dot and positive are kept aside at side by side, and they are asking what is the value of E2. Now a case arrived. You have to keep m di by dt or minus m, which you will keep. See, as in a transformer, I told you, see, as in a transformer, you observe this case very clearly. See, this is one case. See here, observe. This is very important. Dot here. See, observe. Friends, listen carefully. This is an example of pure transformer. Current enters the dot. Here, current enters the dot. In second case, current has to leave the dot. This is the correct correct what you can say, correct current direction. You take second case. See, just observe. It will take some time. Let me take some time. Very important. Listen friend, listen. Keep a mind here. Calm and cool. This is a dot. Current enters the dot. Suppose if dot is given here, current has to leave. Now this is the current direction. First case current is like this. Second case current is like this. Now, first point you note, if current in primary current enters the dot, in secondary current leaves the dot. First point is clear. Now come to second point. Observe, listen, very important. Listen, dear friends, listen. This is dot na. Always primary act as load, secondary act as source, because see, this is dot. Current is leaving and giving power to load. This is an active, like acting as a active device, means it is giving back the power. Dotted, it is giving back the power to load. It is consuming power. Primary is consuming power for production of flux. Secondary, by producing EMF, it is giving power to load. So secondary act as a source, primary act as a sink. Very important this concept. If you remember simply like this, you will never get wrong in gate exam. First point, if current enters the primary in second, it has to leave the secondary, because transformer is a negative coupling device. How you can say negative coupling device? In future I will discuss that. Phi 2 dash is opposite to phi 1. That is the case. Now primary act as a sink, secondary act as a source, because secondary will produce power, will give power to secondary load. So you got this. So for sink, see, if this is a resistor, this is a source, this is a voltage, this is a resistor. For a source, current always enter for positive terminal. For a source, current always, for a source, current always leaves the positive terminal. For source, current always leave from positive terminal. For passive device, for load, current always enter at positive terminal. Hope you understood the terminology. For source, current always leaves the positive terminal, active device. For sink or for load, current always enter at positive terminal. This concept you applied here. See, you apply this concept here. In this case of transformer, you apply here. This is source, this is positive terminal. Current entered the source. Sink, I told you primary act as sink, so this is a positive and this is a negative. In secondary, I told you current leaves the dot. Current act as a, here secondary act as a voltage source, so positive here. Here this is a case of voltage source. This is an example of resistor. Primary act as a sink, secondary act as a source. Now you got way to keep. First thing, current leaves the dot terminal. Second, secondary act as a source. So for where it is leaving, that is a positive, because from there it is going to load and load consuming power, secondary is giving power. For primary, it is absorbing I nu current to produce flux, so it is a sink. So this orientation is correct. So you will get positive sign here. You will get positive M. You won't get negative here. You won't get negative there. You will get positive because Lenz law is already implemented. What Lenz law said? At primary, current enter the dot, secondary it has to leave. To satisfy the phi 2 dash equal to opposite to phi 1. Phi 2 dash is opposite to phi 1. It is Lenz law is already included. So you won't keep here negative. See here in this terminal, now current is leaving the primary source. Here primary, I told you primary act as a sink. So this must be a positive, this must be negative. Okay friends, in secondary what I have told you, for secondary, since current has left the I1 terminal, current has to enter the dot. In first case, current leaving the dot. See, primary current leaving the dot. In secondary, current has to enter the dot. In secondary, current has to enter the dot. And primary act as a sink. Sink means this is positive, this is negative. Now in secondary, current is entering like this. So it act as a source. It act as a source means current is entering like this. So this must be positive, this must be negative. But see how the direction at terminal given. How is the direction at terminal given? It given opposite. Lenz law is not satisfied. Lenz law is not satisfied. So what you keep here? You kept here negative sign. E equal to minus m d phi by dt. So once again listen, you need not to tell always minus n d phi by dt is correct. Minus n d phi by dt is correct because it will depend upon the terminal polarity. Okay friends. So friends, hope you understand this very important. If you understand these two cases now, however it give in current, that is however it given in GATE exam, you will answer correctly. So again I am repeating, first point you have to note that if in primary current enters the dot, in secondary it has to leave the dot, because transformer is a negative coupling device. Second point, primary act as a sink, secondary act as a source. If you know this, it's over. Game is over. How difficult the question may be, game is over. Khel khatam. Next, move ahead. Now friends, take this example to clearly understand. I took an example. See this. I have told you na. This is a GATE example I have took. GATE 98. See how easy it become for you after understanding this concept. How easy it become. Take an example here. Solve friends this case. L1 is 4 Henry, L2 is 5 Henry, L3 equal to 6 Henry, Now the mutual inductance 1 Henry, 2 Henry and 3 Henry. The dot terminals are given, are shown like this. Shown like this. This is a gate exam question. See, I am discussing. If you know my understood my concept clearly, how it become. See, yeah, see. Take an example of L1. Take an example of L1. Take an example of L1 here. L1 and L2. In L1 current entering the dot, in L2 current is leaving the dot na. Dot is here na. See clearly. Dot current is leaving the dot. So it is opposing. M is 1 Henry opposing. In L2, take an example now L2 and L3. L2 and L3. Take an example of L2 and L3. Current leaving the dot in L2. In L3 also current leaving the dot. So it is adding 2 Henry. Take an example of L3 and L1. Here current entering, here it is leaving. So it is opposing 3 Henry. Opposing means minus 3 and adding means plus. Now L equivalent. Now L equivalent, you know, positive 4, it came positive 4. For L1, L2, L3 always positive. Now minus 1 because current, see here, opposing means minus 1. Now minus 3 means opposing. I took first L1 I kept 4 Henry. Then mutual inductance between L1 and L2 is negative minus 1. Mutual inductance between L1 and L3 is negative minus 3. Then I took 5 Henry plus 5. Mutual inductance between L1 and L2 is negative minus 1. Mutual inductance between L2 and L3 is adding positive, so I kept positive 2. Same L3 6 Henry. L3 L1 negative minus 1. L3 L2 positive plus 2. So if you get equivalent, you will get 11 Henry. Hope you understand clearly. Again listen how you will solve. First you take L1 4 Henry plus mutual. Next mutual can be positive or negative. Self always positive, mutual can be positive or negative based on dot direction. See, first you to put 4 Henry, okay, then L1 L2 opposing minus 1, L1 L3 opposing minus 3. Next L2 500 you kept, L1 L2 negative, L2 L3 positive, then L3 you kept, L3 L1 negative, L3 L2 positive. If you kept like this, you will get 11 Henry. So it become very easy once you know the concept. Networks, inductance, transformer, all are interlinked. So I have discussed the basic formula of inductance to revise you. You understand why I have taught you this formula, because all are interlinked. In last classes I have told you THD losses, power electronic divisor, distribution system, all are interlinked. So it's not like that you just read a transformer as a subject you go there. No, all are interlinked. You should understand the basic examples. Hope friends you understood that. If you like my video, please, if you at least got 1% advantage, it is free of cost. You just like, press on like button. Which subject you want, you go. My channel name is Electrical Master. My subscription I have started 2-3 days before. Subscription is less. If I get 200 subscription, just go and subscribe there free of cost. You tell which subject you want me to start there, I will start there. It is all free, no paid courses, free, just your wish. Thank you for watching. Please like the subscribe button, press the subscribe button in Electrical Master and like it. Thank you friends.